Hello and welcome to another recording for S2. This is May June 2025 6-1. Let's start solving. Okay, the first question is it is known that 1% of houses in a certain area have a wind turbine. A random sample of 400 houses is chosen at random for a survey on domestic heating. The number of houses in the sample that have the wind turbine is denoted by X. Use the suitable approximating distribution. So right now it's a binomial with n 400 and p 0.01. So I want to calculate the probability of x less than or equals to 3. So that means 0, 1, 2, and 3. Okay. I will need lambda 400 into 0.01. That gives me 4. So this becomes e power minus 4, 1 plus 4 e power minus 4 over 4 square over 2 factorial plus 4 cube over 3 factorial. Okay, let's check. 3, 4. Okay, I'm accumulating. So the answer that I'm getting is 0.433. Okay, let's move on to question number. There was an easy 3-mark question. I'm going to get full marks for the working that I've shown you. Let's see question number 2. Since I already solved this before, let me just erase this and solve it again for you. Okay, this says the random sample X has distribution this. A random sample of 100 values of X is chosen and the sample mean X bar is found. Find probability of X bar is greater than 6.2. You are not expected to use a continuity correction. You shouldn't be correction for either. Um, so first I'm going to calculate NP and say that the mean of the binomial distribution is 6. Okay, a random sample of 100 values then taken. And NPQ is also required. So I'm going to also calculate 8 into 3 over 4 into 1 over 4, which is 1.5. Okay, so that's sigma square. I want to calculate probability of X bar is greater than 6.2. Okay, so what distribution does X bar have? X bar has a normal distribution with 6 comma 1.5 divided by 100. So probability of z greater than 6.2 minus 6 over root of 1.45 over 100. Okay. You should see the difference between 8, how I'm using 8 and 100. Okay, let's quickly go on and see if we can find a value for z. So z is greater than 1.633. Okay. This becomes 1 minus 5 of 1.633. I have my normal distribution table here, 1.633. So 9487, 9487, 1 minus 0.9487. So 0.0513 should be my answer. Okay, I hope that's the correct answer. Yes, it is. Let's move on. It says part B says that state why the central limit theorem was needed in the calculations in part A. Why was it needed? Because the distribution in this case wasn't specified whether it was, in fact, it was specified that it was binomial. Okay, the distribution of X was not normal, it was binomial. Therefore, CLT was needed. Okay, and why was I able to apply CLT? I can say that n was large, therefore I was able to apply CLT. Okay, that was question number 2. Easy question again. Let's look at the third one now. It says the time in minutes for a certain daily bus journey is normally distributed. The bus company claims that the mean of T is 45. So is 45. Passenger believes that T is actually greater than 45. So this looks like a hypothesis question. Let's see. She notes that the times for the journeys on a random sample of 60 days, the results summarized below. Calculate unbiased estimates of the population mean and variance. So 2750 divided by 60. So I'm getting 45.833. Okay, so that's unbiased mean. Unbiased sigma square is 60 over 59, and then 127,000 divided by 60 minus 2750 over 60 square. Okay, so I am getting 16.243. So I'm going to round that off to three significant figures and say that these are my answers, 45.8 and 16.2. Test the belief at the 5% significance level. So I'm now going to write my null and alternate hypothesis. I noted it down earlier. So mu equals to 45, and I'm hypothesizing that's now greater than 45. Then I draw my critical region at 5%. Okay, so what am I getting at 5%? 5% is 95%, so that's 0.645, 1.6. So then the z value of test statistic is x bar. X bar came out as 45.833 minus 45, 16.2 over 60. Okay, those are the numbers that I'm going to use. 16.243. One point six double zero 1.601. Okay, is that inside or outside the critical region? Okay, I think it's outside. It's 1.601. So 1.601 is less than 1.645. Okay, fail to reject H not. There is not enough evidence that mean has increased. What mean? Let's talk about mean time. Mean time. Mean time is more than 45. Let's put it that. Okay, that's the correct way of saying it. Okay, moving on to question number 4 quickly. It says at an entertainment center, the cost of using a particular video game is zero point 0.4. The number of minutes which people use the video game has mean 15 and variance 9, and the mean and variance of the amount of people pay for using the video game. So cost. So cost will have a mean of 0.4 into 15. That's $6. And variance is going to be zero point 0.4 squared into 9. Now it has 1.44. Okay, both correct answers. Easy 3-mark question. Each day, 35 people independently use the video game. Find the mean and variance of the total amount paid by 35 people. Okay, so cost had a mean of 6 and one video game. Now there are 35 video games that people are paying for, right? So total cost will have a mean of 35 into 6. 210 is the mean. Total cost variance is also going to be 35 into 1.44 because multiple observations of the same variable. So 50.4. Okay, there's a difference between squaring and not squaring, and you need to know that difference. It's pretty detailed in the chapter, right? So there's just one question out of it because I'm choosing the video game 35 or 35 observations of the same video game. I'm just multiplying by 35 and not by 35 squared. Okay, the random variable w and x have independent distributions, this and that. Find w plus x. So w plus x have a Poisson distribution with 3.5. I want the probabilities of 3, 4, and 5. So e power minus 3.5, 3.5 cube over 3 factorial plus 3.5 power 4 over 4 factorial plus 3.5 power 5 over 5 factorial. Okay, let's cumulate. This is giving me 0.537. The random variable s is the number 100 values of w and 200 values of x. Very similar to the November question that we did. Use a suitable approximation to find probability of s greater than 600. So 100s will have a lambda of 120. 200w will have a lambda of 460. Okay, use a suitable electron. Okay, sorry, this wasn't 10x. Okay, 10. I think I've done it the other way around. Okay, let's do this again. 100w will have 120 and 200x will have a Poisson distribution of 460. S is 100w plus 200x. So it has a lambda of 120 plus 460 is 580. Okay. Since lambda is large, use normal. Probability of S greater than 600. First, I'm going to do a continuity correction. So I will have S greater than 600 and 100.5. Probability of Z greater than 600.5 minus 580 over root of 580. Okay, those should be the values that you're working with. Okay, let's see. What do we get? Probability of Z greater than 0.851. Okay, three decimal places because Z is to 3 decimal places. 851 from my table. 8026. 974. So 0.197. 23SF. Okay, I've highlighted part B. Someone else, I think. Solve it again. Okay. It says the random variable y has the Poisson distribution. This, it is given that probability of y equals to 3, y equals to 4 equals plus probability of y equals to 4 equals to probability of y equals to 5. So let's calculate. E power minus lambda to lambda power 4 over 4 factorial. E power minus lambda, lambda power 5 over 5 factorial. The first thing that I can do is get rid of this. Okay. The second thing that I want to do is first simplify the denominators. So I have lambda cube over 6 plus lambda power 4 over 24 equals to lambda power 5 over 120. Okay, let's take a common denominator here. It's going to be 24. So 10 lambda cube plus lambda 4. Okay, 5. So 50 lambda cube plus 5 lambda power 4 equals to lambda power 5. Let's move everything to one side first. Lambda square can be taken, lambda cube can be taken out as common. So lambda square minus 5 lambda minus 50. Either lambda cube equals to 0 or lambda square minus 5 lambda minus 50 equals. Okay, I can factorize this lambda minus 10 and lambda plus 5, I think. So lambda equals to 10 or lambda equals to minus 5. Not possible. Lambda equals to 10. Was that what I wanted to find? Find the value of lambda. Yes, that is what I wanted. Moving on to question number 6. A manufacturer of cell phones claims that 25% students own a pumpkin phone. Jairaj thinks the proportion of students in his college who own a pumpkin phone is less than 0.25. So P equals to 0.25 and P is less than point. He plans to test the manufacturer's claim. He chooses the random sample of 30 students at his college. This was that if 30 students at his college, if the number of students who own is less than 5. Jairaj will reject the manufacturer's claim. Which one was the manufacturer? This is the manufacturer. So basically, rejection region is for H naught, rejection region for H naught. X is less than 5. Okay. What is the question asking you? Given that the true proportion of students at the college who own a pumpkin phone is 10%, use a binomial distribution to find the probability. Okay, so what is the probability of a type 2 error? Write that down. It's probability of acceptance region using new P. The probability of X greater than or equals to 5 using new P. Now, wrong calculation, I think. Probability of 0, 1, 2, 3, and 4. 1 minus 30C 0. What is the new P? New P is 0.10, 0.1, sorry. And this should be 0.9, then 30 minus 0, 0.1 power 0 minus 30 is 1.9 power 29, 0.1 power 1, 30C 2.9 power 28.1 power 2, 30C 3.9 power 27.1 power 3, 30C 4.9 power 26.1 power 4. Okay, let's do the binomial. In this case, it's I think. So overall, it's giving me 0.175. Okay, that is the correct answer as well. Okay, and it says at Florence's college, in a random sample of 40 students, it was found that five on a pumpkin for one. So five is your test statistic. Okay, so 5 is the test statistic. Calculate an approximate 95% confidence interval for the proportion of students at Florence's college who own a pumpkin phone. So PS is then 5 out of 40, which is 1 over 8, is 0.125, I think. Okay, so 0.125 is a formula for that. For the confidence interval, 95% means I want to take 97.5 from here, 1.96. Okay, so minus 1.96. And the formula here is PS, QS, which is this, over N for this side, and 0.125 plus 1.96. I run out of space now. Okay, let's calculate that quickly. But it gives us, it's giving us point, sounds weird, 0.0225 and 0.227. Okay, I think those are the correct answers. Let's move on to the last question that we have. The last question is X is a random variable with the probability density function. So continuous random variable. Show that probability of X less than half is half plus half y. So less than half is 0 to half. I need to have my calculator in radians. So this becomes X plus sine pi X over pi, 0 to half. Half plus sine half pi over pi minus 0 plus sine of 0 over pi. So that gives me 1 over 2, that gives me 1 over pi, and then 0, 0. So 1 over 2 plus 1 over pi. Simple proof. Easy 3 marks. Then it's part B, that's tough. It says expectation. Let's calculate the expectation. Okay. I want to show you the expectation. So x, f of x is this entire thing. So x into 1 plus cos pi x. 1 plus cos pi x. And I integrate over the entire limit 0 to 1. So x plus x cos pi x. X square over 2. And then isolate for this one. Algebra, trigonometry, use x. V dash is cos pi x. V is sine pi x over pi. U dash is 1. So Vu minus integration of dash. Vu is x sine pi x over pi. Sine pi x over pi into 1. So I get x square over 2 plus x sine pi x over pi minus cos pi x over pi squared, 0 to 1. So 1 over 2 plus sine pi over pi plus cos pi over pi squared. Okay, minus the first one is 0, the second one is also 0, plus cos of 0 over pi squared. So half sine pi is 0, so that becomes 0. Cos pi is -1, so -1 over pi squared, and then other -1 over pi squared. Okay, 1 over 2 minus 2 over pi squared. I think that's the proof that I wanted. Yes, that is the correct answer. That is the end of this exam. Thank you for watching.